Flutter makes the UI story easy, but the performance story is harder. When you push a big data loop into Rust, do you actually win enough to justify crossing into native code? This is a direct Dart FFI benchmark, not a Flutter Rust Bridge package benchmark. That distinction matters. Tools like Flutter Rust Bridge remove a lot of manual glue, but the lower level boundary still exists, so this test isolates the cost underneath that architecture. The setup uses one seeded uint 32 list workload, 2 dataset sizes, 40 rounds, and the same checksum path in both lanes. Pure Dart mutates the buffer in process. The Rust lane copies each batch into native memory, Rust transforms it, and Dart copies it back while a sampler watches peak RSS. The repo is split the same way the claim is split: shared workload code, a pure Dart harness, a direct FFI harness, and a tiny Rust C dynamic library. That separation makes the comparison auditable instead of anecdotal. On wall time, Dart Rust FFI is the clear winner at 12.13 milliseconds, mean versus 117.25 milliseconds for pure Dart. Throughput follows the same shape: 8,108.94 megabytes per second versus 856.31 megabytes per second. But the distribution matters more than one average. Across 5 runs, the FFI lane stays consistently faster, and the pure Dart lane stays consistently slower. This is not one lucky run. The scaling view is even more useful. At 256 KB and at 1 megabytes, Rust stays ahead on speed, and the larger dataset keeps the same ordering instead of collapsing into noise. The trade-off is the reason this video exists. Pure Dart wins peak RSS at 32.71 MB versus 34.54 MB. If your app is memory dense or simplicity first, the native boundary can matter more than the speedup. The code explains why. Dart spends cycles moving bytes through Rust Bridge process chunk, and Rust only owns the hot transform loop inside FFFI process batch. The compute is native. The transfer is still work. The terminal trail is simple. Verify the Dart path, compile the Rust C dynamic library, run both benchmark lanes, and write the report. The verdict artifacts are generated from that run. So the answer is yes. Rust behind Flutter can be much faster here, but this result is specifically about direct FFI. Use it as the floor for the boundary cost, not as a claim that every Flutter Rust Bridge setup will behave the same. The practical rule is narrower and more useful. Push compute-heavy loops into Rust when the speedup clearly pays for the transfer. Keep the work in Dart when memory density, simple state flow, and lower integration cost matter more.